Hi, everyone, and welcome to Quarantech Tuesday. As we wait for everyone to jump on here, I'll give a brief introduction. I'm Abby Weber, and I'll be your host today. I work on the marketing team here at A-Laser, and for today's webinar, we are excited to be featuring Joe Azevedo, Sales Manager with A-Laser, to discuss the benefits of laser processing for circuit board materials. If you've joined us for Quarantech Tuesday before, you know the drill, but for anyone here for the first time today, the webinar will be recorded and will be available to all registrants and attendees through a link that you'll get in your email tomorrow. We would love to hear from you during today's presentation, and there will be time for a Q&A session towards the end. You'll see the Q&A tab at the bottom of your screen, so feel free to throw any questions you have in there. If we don't get to your question during today's webinar, we'll be sure to follow up, or you are always welcome to contact us directly. Now let's jump right in. Joe, you have the floor.
Thank you very much, Abby. Thank you very much. Hello, everyone. Thank you again for taking the time out to register for this webinar and get some information about our laser services at A-Laser. I'll tell you a little bit about the history of where we're at and where we're going, and thank you again. So again, a brief history of A-Laser and how we started. Founded back in 1993, back in Beaverton, Oregon. They were servicing the Silicon Forest technology area. So in 2004, FCT Assembly acquired A-Laser, kind of merged together, expanded the network of a business, expanded the technology that they were using, and tried to find some new opportunities within the laser technology. So in 2010, FCT moved A-Laser to the facility that we're currently at in Milpitas, California. There they found the opportunity to be in the heart of a lot of R&D, a lot of NPI type of work, and with still some production going on in Silicon Valley at that time. So at that time, I joined A-Laser previously from being with FCT at their stencil company. And then I just kind of did a lateral move in 2010, moved over to A-Laser, first in a customer service role. So in 2015, about 5 years later, we've just established more of our technology, more of the opportunities that we found. That we increased our capital equipment and increased our knowledge and how to benefit customers with additional services, doing all the laser processing that we can, and not only precision parts. So today, as A-Laser continues to innovate and grow and seek out new opportunities, we are also thinking of 3D printing, but incorporating that with our precision laser parts and how to provide more value to customers on that side, seeking some rapid R&D work, but getting still precision components coupled with that technology as well. So a little bit more about myself. I am from California, born and raised in San Jose. Way back then, when there was no Silicon Valley, moved our family out to Gilroy, California, where I currently reside, and about 24 years ago already. So the incentive back then was to move away from a very high-cost housing market already 24 years ago in San Jose. They were kind of pricing us out, so we moved out here in Gilroy, much smaller community, about 56,000 people, a lot of farmland. As soon as you go a mile from my house, and you see nothing but farmland, so it's kind of nice. So today we're going to talk a little bit about laser processing PCBs and how we do that with A-Laser. Again, we do other services, including precision parts, and I can talk about that afterwards, but we'll just try to overview the laser processing that we can do at our facility. So it's again, we use lasers. That's our choice of means of producing parts and producing services, both with commercial and R&D type of work, and as well as the contract assembly manufacturers. So we'll talk about laser depaneling. We'll go over, again, laser routing, laser drilling, and laser cutting of all flex circuits. And again, after the presentation, if you have any questions, general questions, I'll try to answer them as best as possible. And if you have any more detailed questions, yeah, please feel free to email me and we'll go from there. Thank you. So laser depaneling is probably the most frequently asked service that we are doing at A-Laser. And we provide the service because customers are really seeking that high precision tolerance and trying to depanel these boards that might be very sensitive components to them. So why laser depaneling? Because due to the minimal space between boards, there is more value per board. And if you've nested them really close, you want to find a solution to depanel these boards. Early on, if you're really early on in your design stage and you'd like to nest boards more per panel, and you know you're going to use laser technology, that's a really good method to use, thinking you can possibly get 20% more boards on a panel, which would really help in your throughput. So again, the laser technology allows for a closer nesting of the boards. It allows for more intricate board geometries to be cut. So now we're getting customers that are trying to find solutions because they have these designs that they can't get cut and depaneled with a traditional router. The bits maybe too large. There's a lot of vibration. So the laser technology, which is a spot beam size of 20 microns, that will allow you to get much tighter geometries and more sharp corners, really fine profiles. So another advantage of using the lasers to depanel your boards is it does keep the delicate components and those really fine soldered components on the board without any chance of them breaking apart or getting vibrated off because of the added stress. We've have components now that we're seeing soldered lasers, very sensitive sensors, really fragile components really close to the board edge too. So traditional routing method, different methods that they are using today, quite often damages those type of components. So laser depaneling is a really good option for that. Again, yeah, if components are placed too close to the board edge, that would be another reason to seek laser depaneling for that specific project. And we've had components that are placed 4 and 5 thousandths from the edge. I mean, really tight spacing, usually really small boards, not a whole lot of real estate, and they're trying to pack as much components on these boards as possible. So it's a good solution for that. And the laser cuts again with the beam, so you will get a really clean cut edge. There'd be very little no debris. And that's a good choice, especially when something's going to be fit into a housing or some kind of a overmolding or something like that. I will tell you that there will be some, usually there is some discoloration on the cut edge. That's usually worked out by either cleaning by several methods, a dry wipe or a light IPA wipe, or sometimes I think in 2 cases we've had customers request that we get them plasma cleaned for these particular boards. That is really for a special project. And in some cases, the cut is clean enough and the customers just take them right off the laser, and we're happy to provide that too. So laser depaneling versus other methods like punching or die cutting or V-scoring, sawing, water jetting, or traditional a router bit. Those all usually can inherit potential damage to the board. And I know a lot of cases they don't. They're used quite often. They're used quite well. But when you're talking about really sensitive assemblies, potentially micro assemblies, laser depaneling, using a laser to depanel is a really good option for that. Again, we've worked with many customers on finding a solution for this particular project. A lot of times it might be just for that specific project or that specific customer that they have may need laser depaneling. Otherwise, other instances, they can use their traditional routers to depanel the boards, and that works for them. So laser routing. One of the benefits, as you can see, these machines that we have are capable of laser routing and creating the geometric patterns and circuitry patterns that are needed. One of the benefits of a laser routing is clean burr-free cuts or with no shape limitations. You can get very clean and accurate circuit paths. Again, there's no change of drill bits. You're just going to be using the same 20 micron beam on all the systems that we have. It's the same technology, whether we're doing laser routing or laser depaneling or cutting flex circuits. It allows for the vaporization materials rather than just burning through. So again, it's ablation. It sounds like a harsh word, but in this technology, it works really well where everything is just obliterated. And the way the debris is kept off the surface on all these systems is the lasers have a honeycomb bed that the boards or the substrates lay on, and they also have vacuum in the laser head. So at all times there's debris being pulled up and away, or as the laser does cut through, in certain instances it is being pulled down and away too. So it really keeps the surface much cleaner than traditional methods. So again, why A laser for laser routing? The ability to adjust the power, the repetition rates, and these lasers are very repeatable. Once the tool is locked in, it's a very repeatable process. So it's really good for production runs if you really need the production support. But it also shows you the quality you can get just to make sure you have very accurate and consistent R&D and NPI work or proof of concept work. You want to see how this will work for you and what will work for your customer in the end run. So in support of in all the technologies that we do have a dedicated team of engineering and CAD teams they're going to work with you and work with the sales to communicate what's the best option for our customers. So they will through evaluation of the CAD data, of the Gerber files, anything you can provide, even viewing the actual sample panels. They're going to flag any potential areas of concern. They're going to get best options for laying out the PCB. If we're brought in early at the early stage of planning, they can help you plan what's the best spacing that you get, what's the tightest spacing that you can achieve for this particular project. They'll work with you on fiducial placement, what's going to work best, what type of fiducials will work best. Incidentally, it's a 40 mil round. Fiducial works best. 40 mil round and lower actually works best. So they'll work with you, our customers, on that, trying to answer questions beforehand. And if you already have something that's established and you want to get something routed or some boards routed or some boards depaneled, whatever that is, and it's already done, at least the size, they'll work with you again on the best options that are available. So laser drilling, again, the machines that we have are capable of laser drilling and laser drilling vias and so forth. So advantages of laser drilling would be the CAD drilling. It's for the accuracy. They can drill the holes in circuitry that has a dense pattern and allows PCBs to be stacked in multiple layers. Lasers are controlled in a precise manner so that the internal copper is affected. Again, there's no mechanical tooling needed. Again, it's just that beam of light that's being controlled. The beam of light is being controlled by the pulse width, the frequency, the power. It's also being controlled by the speed of which the laser moves, the number of laser passes. All the lasers that we do use are controlled in a series of laser passes in an area which is called a scan field. Scan field is 50 millimeters by 50 millimeters, and all the lasers work within that scan field. And if most parts are larger than 50 millimeters by 50 millimeters, another scan field is added, and it goes and so forth. So you'll see on the screen, if you're ever to see the screen of the computer of how these lasers are operating, you will see the image of your circuit path, of your board, of your PCB, whatever we're working on. That will show up with the multiple scan fields on there. So the lasers are very accurate, plus or minus 1 mil to 2 mils in most cases. Some cases a plus or minus half a mil on the tolerance depending on the project. So that is project specific for plus or minus half a mil. but in general, plus or minus 1 to 2 mils is most of the work that we do. Again, it also will depend on the integrity of the boards that we receive. So if you have a supplier of the fab that is a little out, if they're telling you, hey, their accuracy is a little bit larger than the normal, or it's a plus or minus 5 mil, then our accuracy really will only be as tight as plus or minus 5 mil if everything is laid out to that tolerance. So again, these lasers are very accurate. So we will flag that if we do find any kind of discrepancy and let you know how we can solve that issue. So laser cutting flex circuits is another popular service that's come our way for many projects. These UV lasers are really geared for cutting Kapton or polyimide. It's a material that we cut probably on a daily basis, not only for a flex circuitry, but often for precision parts, polyimide in the range of 5 mil thickness to about 11 or 12 mil thickness for a Kapton type of material. And then after about 12 mils to about 40 or 60 thousandths, it's called Cerlix, where they laminate the Kapton and make it more into a rigid material, which is often used for stiffeners in many projects. So we will cut a lot of Kapton stiffeners for customers, stainless steel stiffeners for an example, and other projects. But for cutting flex circuitry, yeah, the lasers are the way to go. I mean, there's going to be, again, no vibration. Excuse me, the lasers kind of cut through this material almost like butter. It's a really good wavelength marriage between these two technology and the actual material. So part of the benefits, again, of cutting with the UV laser systems that we have, it's you're going to get the fine, accurate cuts. You're going to get very high precision. There's going to be no mechanical stress. There's not going to be any heat distortion to the circuitry. And again, it's going to be a very repeatable process. So a lot of customers ask when they're going to send their assembled boards or their fabs to us, is the area ESD safe? So yes, it is. We do have a certified ESD certified area that the lasers are located in. We do practice all the safe procedures to handle assembled boards or sensitive fabs. Anything that needs ESD protection, it is done in an ESD safe environment. So again, we keep our records in tune with everyone. So if there's ever an audit or your customer needs to see those, we're happy to provide that type of information for you. Again, it's the fluorine compliant packaging we use, clothing, of course, and humidity ionizers. And just talking about a little bit more on ESD protection, when we do work with customers on projects, we would like to work with you early on to find out how things will be packaged from your side. You know, we have standard ESD bags, and we're happy to provide those for you. But if you need the boards or fabs or anything placed in ESD foam boxes, or perhaps in gel packs, or perhaps in the ESD trays, yeah, we'll work with you on that, either acquiring that, or if you're able to provide that material, we're happy to accept that and use your packaging and even establish certain packaging methods. So I mean, it could be as critical as removing parts off the laser with a vacuum tweezer, perhaps, and placing them in an ESD foam trays, anything like that. So we're happy to do all that. We'll work with you. Again, offer suggestions if you're concerned about how are things going to arrive, how things are going to be handled internally, and how are your parts and your packaging going to be sent back to you, and you'll feel confident about that. So I have a quick video to show you about this process. move on to the next slide. Oops, excuse me. So for, did I skip one of it? Okay. Okay. So we're often asked also, how do we inspect parts, or how do we inspect anything internally that we're working on for our customers? So we do have two coordinate measuring machines, two CMMs that we're utilizing for all the work, whether it's a one part R&D project to, it's a 100,000 part production run. So we can inspect for AQL high level quantities. We use these machines to confirm board geometries, laser cut locations to measure distance, coordinate distance. We can certainly do that for our customers. Again, all projects that are run in-house go through a first article inspection before any production is run. That is checked with the technicians. If there's any adjustment needed, we can usually do that adjustment ourselves. We don't need to go back to adjust an inner or a part that's too small or it's not meeting tolerance. We'll make that adjustment off the original data that we receive from you. We'll make the adjustment, do another first article. Everything checks out, everything's in spec to the tolerance, then we'll run the production. So with quality, in that it also will be a good way to check if there's any issues along, let's say, a production run. We get the first set of panels, let's say it's 100 panels that we run, it's no issue, everything runs fine, and we get another lot of 100, and then we notice after the first 10 panels that we're seeing some kind of a drift, perhaps where the panels are stretched or something like that, or shrunk. We'll catch that and we will flag that and then communicate back that to you and how the adjustment can be made. And sometimes the adjustment is just stretching the data to match this particular board for this particular run, or sometimes just aligning differently to how boards are run or how they're routed. Again, there's always ways to solve issues as they come up. Again, we will see occasional non-conformance because these lasers are so accurate. And in a production run of the fab house, they might have stretched a couple of mils out of their tolerance. And we're really keen on catching that and relaying all this feedback to the customers. So we can work it out and get you really high precision work at the highest quality we can provide. So I think that's it for the initial presentation. Again, I think we're going to have some question and answers right now, but if you do have any specific questions about specific projects, yeah, please email me at jazevedo@fctassembly.com. I believe you will get all this information from my colleagues on all this, and if you have any general questions, I'll be happy to answer them now or anywhere. Again, if you do need an NDA signed before we start exchanging any real detailed ideas or data, yeah, please send that in to my email address. We usually can sign and have an NDA signed within 24 hours. So thank you very much.
Thanks, Joe. Yeah, as you said, let's open the floor for questions. I think I did see one come through here. Tony asked, how many vias can be laser drilled per hour?
I actually, hey, Tony, thanks for asking the question. I don't know the actual throughput vias per hour. I guess that's going to depend on usually for everything that we do with the laser, it will depend on the size of the vias, the substrate that we're cutting through, the stack up that's being there, and if there's any pretty much those two questions. So I'd be happy to answer your question a little bit more detailed. Throw it. Email me a number or anything like that. We'll be happy to work with you. But it's generally it's the size of the vias, the depth, and the stack up the material that we're going through. Those are parameters that the engineering team at CAD will relay all this to the engineering team, and they will see it, and then they'll get back to you of how they can and how many vias or whatever we're cutting throughput. And it does change. 10,000 vias, let's say, on one substrate. Is going to be different from 10,000 vias on the same thickness of substrate, but it's just different internally. So that will affect the time in which how the laser can adequately do that process.
Great, thank you, Joe. And another question, is there a height limitation on the laser?
Yes, there's from the surface of the laser, if you're depaneling or cutting around the laser film, so from the height of where the laser is actually cutting to the clearance of the head, it's 10 millimeters of clearance. So if you, for laser paneling, say for instance, if you have components that are taller than 10 millimeters, there's an option, couple of options. The easiest option would be to flip the board over, create a fixture and cut from the backside. And if there's components on both sides, then hopefully the components on the one side aren't as tall as 10 millimeters, and we can usually do it that way. We've had 2 or 3 projects where, again, this was for a smaller run, probably of 5 to 10 panels, where the real tall components that were much taller than 10 millimeters, they were actually removed off the board from the customer and then soldered back on after that. It wasn't the most efficient way for them, but the need for having the laser do the accurate cuts and the processing that they needed done, it was a win-win for them. They were more willing to do a removal of these tall components and then add them back on afterwards. They just getting the laser profile cut to what they needed was the most important thing at that time.
Definitely. And John asks, what is the smallest via that could be drilled in a 0.2 millimeter thick FR4 board?
Let's see. Well, the spot beam size is 20 microns. I'm going to say the smallest via, I don't recall, but I'm going to say it's probably going to be 4 to 5 mils. Probably it's, even though in theory you would think you can get a 20 micron beam, but the way these lasers do operate, they have a shutter that's open and closes really, really rapid. And at a really small, at that small beam size, when we do cut, let's say holes in, if we were to cut something in Kapton just to see the shape, you can see it really easily. The hole is going to be more of a slightly oblong shape, and it won't be an actual perfectly round hole or geometry. So I think about 100, probably maybe 3 mils, 3 to 4 mils, I think would probably be the smallest we could go. I can confirm that, but I'm going to stay about 3 to 4 mils, probably 4 mils.
Okay. And can you do R&D or just production work?
Yeah, we do R&D. We actually do a lot of R&D in the facility. Being in California, being in the Bay Area, does give us the opportunity to work with a lot of the customers that are that may have production outside of California, but in the Bay Area, it is a lot of R&D that we're doing, a lot of NPI type of work, and it's not just for contract assembly. It's for consumer. It's for medical device. It's for even defense contract work, anything like that. It's a lot of R&D. So it's very common for us to get requests to cut one of something, whether it's cut one panel or cut one part or cut 3 panels or route 2 panels, anything like that. So it's very common, and we're happy to do that work. We are set up to do laser development, kind of a lab setting with a lot of our customers. And prior to COVID-19, we had quite a bit of our customers come in for that type of lab work, for an R&D work. They wanted to work, and sometimes we do encourage customers to come in and work side by side with the technicians on the laser to get their immediate feedback for whatever the process is. And I think as things are opening up now, we're gonna start offering that option again as customers need. They want to have be there, see the parts process on the lasers, have them go to the CMM machines, work with the technician there to view the edge quality or whatever we're trying to achieve, and then that way we can develop that process one-on-one with our customers and really get what they're trying to achieve.
Awesome. And Tony asks, do laser drilled vias have a natural cone or trapezoidal shape? And if so, what is the difference in diameter through the hole for a 10 mil thick laminate?
For all the drilling that we do, these lasers do make a natural trapezoid shape. So it is going to be slightly larger on the laser entry as to the final depth, or for the exit hole if we were cutting something through. So for a 10 mil, I think you said 10 mil diameter. I'm going to say it's going to be about a 0.5 mil difference, I think, at 10 mils.
Perfect.
0.5 mil smaller on the surface or the laser ends as to when the laser enters.
Mhm. And Dan asks, what percentage of your business is drilling raw board panels versus routing out boards? And what other areas are significant percentage of your business?
So yeah, laser drilling is probably one of the lower services that we're providing. We don't get asked that as much as for routing or for depaneling. And I personally, I think it's because a lot of those services customers are still have the machines. Of course, the contract manufacturers have those machines. They're doing that all internally. The needs we see most often are for laser depaneling of the rigid boards or the rigid flex boards, the flex circuitry. That's what we do see the most, and we see that not only in R&D small runs, again 1 to 5 panels, as well as we see that depaneling in production, and the production volumes can be quite high. Where we're turning out 10,000 boards a week, for instance, for some customers, and most of those incidentally seem to be out of state. Again, California seems to be a little bit more of the production, though we do have some production customers in state. Most of that work seems to be coming out of state, but we're happy to take it where we can get it. But yeah, not as much request for the drilling. It's probably 3%, let's say 1%. It's pretty low. It's not as often as depaneling, which is going to be for the service is probably going to be more like 75%. And as a whole, the industries that we're serving, whether we're doing precision parts or we're doing circuit boards to support customers, probably about 40% of our customers that we're working with are in the medical device industry. The others are going, we also support a lot of the semiconductor industry. That's probably another 25% right there. And then the rest varies for defense contract work, consumer electronics type of work. And then we also support some other service industries that may have their own CNC machines, things like that. But for the really thin gauge materials, they'll come to us, and we use us as a kind of a third party a service provider.
Thank you. And Yannick wants to know, is a laser faster than a standard router on FR4 material? If so, what are other advantages?
Yannick, no, I don't believe the lasers are faster, but they will be more accurate, and in that respect, it might save you some time and some frustration on certain certain projects. So yeah, laser technology, it is growing, and we did upgrade to a new laser system a couple years ago. One of the larger systems that's really helping us in our throughput.
Great. John asks, do you use only UV lasers? If not, what types of lasers do you use? Is the type of laser application specific?
Yes, we have 2 systems. We have UV lasers and infrared IR lasers. So the UV lasers with the presentation I was talking about today, yeah, that's all done on the UV systems. The UVs, they are excuse me, they're 355 nanometers. If that means something, they're 355 nanometers again, very controlled with power, speed, and frequency. Again, they're really spot beam size of 20 microns. So those are more versatile, I would say, in the opportunities that we're able to provide services for. The UVs are cutting polyimide, they're cutting Kapton, they're cutting PEEK, and then FR4, and then they're also cutting thin stainless steel, they're cutting copper, cutting beryllium copper, tungsten, nitinol, let's see, different rubber materials, silicon rubber materials, graph foil materials, Buna N rubber, a lot of different type of materials like that, brazing alloys. So the UVs, that spectrum works well with a lot of different materials. The infrared lasers we have, they are cutting only stainless steel alloys. Again, it's from thin gauge alloys from about 4 to 5 mils up to 25 mils. So we will cut stainless steel stiffeners for contract manufacturing. We cut a lot of those, but we're also cutting a lot of precision parts for, again, the industries that I mentioned, medical device, contract manufacturers, anybody like that that's using, that needs high precision micro stainless steel or parts. But yeah, the IR lasers run really hot. They run 1064 nanometers. So we've tried them years before, trying to cut other materials like FR4, Kapton, and that wavelength just really burns the material. It's not conducive for that. So we keep the IRs just for cutting stainless steel.
Great, thanks for going into some detail on that. And Tony asks, does laser depaneling leave a mouse bite effect at the edge?
No, it all depends on the placement, Tony. If the laser has been very accurate, and if we get the placement of where the mouse bites are, where the customer wants the cut, yeah, you will see no mouse bites anymore, or no jagged edge anymore. It'd be really smooth on there. The only time I've seen that is usually when there's a placement or alignment issue. The panels might have stretched or expanded a little bit, and we'll align to get as close as possible. But usually it's very close, very precise, and in a lot of these instances you have to be, because these when we have this type of project, it's usually because these boards are going to be placed into some kind of housing. It's going to be a tight fit going into something that's going to be encapsulated or something, and they don't want or need that extra little of edge abrasion on the parts. So yeah, the lasers are very accurate, and you shouldn't see any edge. If you're not asking for it, you should be able to eliminate that.
Perfect. If anyone has any other questions, I thank you for asking such great questions. But yeah, if you have any other questions and they weren't answered today, feel free to email Joe or reach out to him or us. Thank you all for your attendance and participation. And just as a reminder, this webinar was recorded and you'll be getting access to that through a link in your email. And be on the lookout for future topics. We look forward to seeing you in May for the next Quarantech Tuesday. And thank you again, Joe, for such an awesome presentation.
Appreciate your time. Thank you.
Thank you. Have a great rest of your day.
Thank you.